learning. No, come on. Last video, we learned how to calculate surface areas. And we're going to be using that knowledge to help us learn how to calculate volumes and learn what volumes are. So in this video, we're going to be learning how to calculate volumes of prisms, cubes, and also pyramids. So let's get right into the video. So now guys, let's get started with, learning what volumes are. Remember when we learned about areas and that 2D objects have something that we call an area, which is everything inside of it? Well, a volume is the same thing, but in 3D. It's the filling everything which is inside of a 3D object. So first of all, how do we calculate the area of a cube? Really simple, but just gotta memorize this formula, guys. Let's imagine we have a cube. And let's say that every single side has a length of 5 centimeters. To be able to find the volume of the whole cube, I will have to do 5 times 5 to find the area of our square. And then now that we find that that is 25, just imagine if you had like a scanner, okay? A scanner, a futuristic scanner. And let's say you're just trying to scan all along the depth, which is right there. And you're just going, and you're scanning with many other squares and multiple layers of this square. Imagine if you just had so many layers and you were stacking them inside of it. Well, yeah, that's what we're doing. First, we multiply 5 times 5 to get the area of the whole square, and then we're multiplying that by 5 centimeters, since that's also the depth, because every single side is going to be equal to the same side, because, well, this is a cube, and every single side of a cube or a square is equal. So yeah, 5 times 5 to find the area, and then the area we're going to want to make it go all the way to the end of its depth, which is going to be 5 times 5 centimeters. So yeah, that's really simple, guys. And so now that we got that covered, let's now learn how to calculate the formula to calculate a prism. There are many types of prisms. And some of these prisms involve rectangular prisms, triangular prisms. Some of these prisms also involve cylinders, which isn't really a prism, but it kind of follows the same principle. And so what I'm trying to say is that all of these kind of have the same way of calculating it. How do you calculate a prism? Well, we're going to want to do this height times the length times the depth. So let's say this was 5, this was 4, and this was 60. 5 plus 4 times 60, and that will give us our answer. And same thing for the triangular prism, which is actually the triangle times the depth. The triangle's area times its depth. Or even with the cylinder, it's actually the area of the circle times its depth. How long it is, its depth. Another important rule, guys, is that whenever you're calculating or multiplying these lengths, like let's say I do 5 times 4 times 60. So if I do that calculation, I won't just say 1,200, but I'm gonna say 1,200 centimeters not squared, cubed, because whenever you're doing multiplication, especially when you're doing areas, or even when you're putting the exponents, whenever you're putting a number, like let's say random number 4, and on top we put 2, that would be 4 squared. What if I had 4 and a 3 on top? That would be 4 cubed. So when it's a 3, it's a cube. Okay, like you get special names up to 3, and 3 is cubed, so that's a special name. And then you say to the power 4 to the power 5. So yeah, and then so it goes on. And by the way, I bet you're wondering what a prism means. Well, whenever you say prism, like I'll give you an example, guys. Let's say you said a triangular prism. Let's say triangular prism. Let's say that you have this rectangle. Not this rectangle, this triangle. Okay, right in front of you. And imagine that triangle was 3D. Okay, imagine if it had lines with the depth, and lines that made up a depth. like a rectangular prism, where you have like the box, right? The box, the rectangular prism, like a box, a toothpaste box, you know, where you get your toothpaste. Well, that's basically a prism. It's just that it's gonna be the shape, as you say, which is gonna be like in our case right now, triangular prism. So we're gonna take a shape which is in our case a triangle, and we're gonna do the triangle, and just make the triangle have multiple layers. Just make it deeper, make it have depth, make it 3D, like the rectangular prism, like the box. Just do that. And that's basically a prism. It's just that you're basically just extending it, you know. Yeah, then like triangular prism, you just extend the triangle. Rectangular prism, you just extend the rectangle. Yeah, it's really simple, guys. Now we're just gonna learn how to calculate the area of a pyramid. So the formula is for the volume is gonna be a third times the base times the height. So let's imagine the height. Remember in triangles you have the height in the center, right? Yeah, in the center, the height from the lowest point from the side, from the segment down there, all the way to its peak at the top. Yeah, that's the height. Well, when it's a pyramid, you kind of see the triangles kind of like face in a 45-degree angle, kind of, right? It's not completely straight. And so you're gonna want to get the height from the base plate, as in the base of the pyramid. So the base is area times times the pyramid's height times a third. So let's imagine that the height was 4. So let's write big H equals 4. The base area 8 centimeters squared. So now you're just gonna want to do a third times base times height. So let's first do base times height. 8 times 4 equals 32. Now we're gonna want to do 32 times a third, which is 0.33. And that's gonna give us an answer of 10.56 centimeters cubed. So that's really simple, guys. I hope that understood what I was explaining. I hope that you enjoyed it. I hope that you learned something new. And if you need any help, be sure to ask your teacher about it, or even just rewatch the video. So yeah, have a good day. Hope all the best for you. And yeah, see you next video. Bye.